This is the ever-changing Earth review sheet. Use it as a little bit of revision, or if you've missed a certain part of a topic, to catch up. So, to get us started, draw and label the four main parts of the Earth. Right in the middle then you've got your inner core. It is solid and it contains iron and nickel. Moving on then, you've got your outer core, which is liquid, but it still contains iron and nickel. Moving then a little bit further out, you've got your mantle, which has properties of solid but can flow. That's where all the magma is kept for volcanoes. And then you've got your crust, which is thin and rocky, which is how we essentially know the what we see every day in terms of the crust. So, how did the Earth come to be how we know it today? So this was discovered by a man called Alfred Wegener, and he had a theory known as the theory of continental drift. He believed that all the continents were originally one continent known as Pangaea. Over time, all the continents spread to form the current continent. So over time, they spread to look like the continents we know. What three pieces of evidence did Wegener give? He said the shape of the continents looked like they fit together like a jigsaw, similar rock patterns but on different continents, and similar fossils but on different continents, which meant that originally all should have been slotted together, because how did the rocks and the fossils get to the different continents? What information do we give to explain Wegener's theory in the 21st century? So we had no way of proving this. So Wegener believed that, but we couldn't prove that Pangaea originally existed. And then eventually we found out that there were convection currents, which essentially means the hot air rises and the cold air drops to the bottom, like in a convection current, which causes the mantle to move around, which causes the crust to move. So essentially the mantle gets hot, moves up, moves the crust a little bit, and then it goes back down when it gets cold. That is the theory that we use to explain that the continents all originally were known as Pangaea and slotted together. That leads us quite nicely on then to the theory of plate boundaries. So you've got three different plate boundaries known as destructive, constructive, and conservative. So destructive plate boundaries, and that's a really easy way to remember it. Plates are moving together, so something has got to be destroyed. The densest plate is pushed underneath and melts. This is the one, and I've drawn a little diagram there, so the one's going underneath the other one. It is getting destroyed. Destructive causes earthquakes and volcanoes. Constructive then, so you're making something, you are constructing something. Plates move away from each other, magma escapes from the gap, and then new rock is formed. So you have constructed new rock. That's how I remember it. And then conservative, plates slide past one another, earthquakes occur. Moving on then to how the original atmosphere evolved. So our present day atmosphere is made up mainly of nitrogen with a little bit of oxygen, carbon dioxide, and a couple of the noble gases. However, originally the Earth's atmosphere contained loads of carbon dioxide. So the starting point of the Earth's atmosphere, volcanoes were emitting loads of carbon dioxide, no oxygen. So it was essentially just the Earth was covered in volcanoes, just ash clouds everywhere. No sun could get through, no animals could grow, no plants could grow. Over time then, the Earth cooled, water vapour in the air from the volcanoes condensed and started to form oceans, and it started to rain. When it started to rain and the amount of carbon dioxide decreased, there was an increased amount of oxygen, so that allowed plants to photosynthesize. And then finally, carbon dioxide decreased by plants and dissolved in the ocean. So that's just a little overview of how we went from being like nearly 100% carbon dioxide to essentially now less than 1% carbon dioxide. How is the level of oxygen maintained in the atmosphere? Photosynthesis. So photosynthesis takes in carbon dioxide and releases oxygen. How is the level of carbon dioxide maintained in the atmosphere? Respiration. So us as humans, we take in oxygen and we give out carbon dioxide. So originally they were in a nice balance. Plants would be taking in the carbon dioxide, releasing oxygen. We would then be taking in the oxygen and releasing carbon dioxide, and exist in a really nice healthy balance. Okay. However, as the population increases, combustion has become more common, which essentially is burning fossil fuels to release carbon dioxide. So that has increased the levels of carbon dioxide in the atmosphere. Increasing the levels of carbon dioxide in the atmosphere causes Earth's temperatures to rise because it gets stuck in the ozone layer and it can't get out. How can we prevent it? Recycling, plant more trees, mass transportation. So instead of driving your car, use a bus. Another thing that's happened now with an increased combustion is when you burn petrol, it releases something called sulfur dioxide, which reacts with rainwater. So it goes up to the clouds and reacts with rainwater, causing something called acid rain. This acid rain then reacts with metals and limestone and causes damage. How can we prevent it? Sulfur scrubbing. So a lot of statutes are sulfur scrubbed to remove sulfur dioxide from them. Finally, a little bit like the flame tests, you need to know 3 chemical tests for different gases. So oxygen, you need to relight a fade-in splint. So a splint that's about to go out, if you put it in oxygen, it will relight. Hydrogen, with a lit splint, it'll give a squeaky pop. And then carbon dioxide will turn lime water cloudy.